Today we're going to look at section 8.3, graphing quadratic functions. Up until now we've been looking at graphs and pulling out information. Today we're going in reverse. We're going to look at the quadratic function and we're going to graph it using the things that we know. There are lots of steps in order to get this right. You may want to write them down so that you can refer to them when you need them. Step number 1 is find the axis of symmetry. You should know how to do that. We use the formula, x is equal to a negative b over 2a, and we substitute in 3 for a and negative 6 for b. When we do that and we simplify, we find that x is equal to 1. So that's our axis of symmetry. It's also the x-coordinate of the vertex. So step number 2 is finding the vertex. How do we do that? We use our x-coordinate, substitute it back into the original equation, and we find out that y is equal to a negative 2. So the vertex is 1, negative 2. Step number 3, we're going to find the y-intercept. Now remember, just like in a linear equation, the constant is the y-intercept. The constant is all that would be left if we substitute 0 in for the x's in the equation. So we'll substitute in 0, and we end up getting 0, 1, because in this equation, 1 is our c. Step number 4, we're going to find 2 more points. Since the axis of symmetry we found was x equals 1, we're going to choose 2 numbers that are somewhere near the 1 on either side of it. We won't choose 0 though, because 0 is the y-intercept. We already have that. So I'm choosing x is equal to a negative 1 and x is equal to 2. When I substitute it in to this side of the equation, you'll notice that I get negative 1, 10 as 1 point. On this side, if I substitute in a positive 2, I end up with 2, 1. Please be very, very careful with PEMDAS. Step number 5. Now I'm going to put everything together. My axis of symmetry is in the green line. The vertex is the blue point. The y-intercept is the red point. And the other 2 points that I have are the 2 purple points. Now, because a parabola is symmetrical, meaning that it looks identical on both sides of the axis of symmetry, I can find another point just by looking what I have graphed already. You'll notice that the red point, the y-intercept, is 1 away from the axis of symmetry. Likewise, one of the points that we discovered was also 1 away from the axis of symmetry, 2, 1. When we graph this other point at negative 1, 10, we find that it's 2 away from the axis of symmetry. Therefore, we can draw another point. The reflected point would be at 3, 10. It's 2 away from the axis of symmetry, just like negative 1, 10 was 2 away from the axis of symmetry. And that's your graph. Last thing that we're going to do is we're going to draw a curve. Notice that the curve of the parabola has arrows at both ends because it goes on forever and ever. We're going to try one together. Step number 1, find the axis of symmetry, or the x. Once you substitute in, you should have gotten that x is equal to 3. Step number 2 is find the vertex. We already have the x-coordinate. Now we need to substitute in to find the y-coordinate. You should have found that the vertex is 3, 2. Next, find the y-intercept. The y-intercept is your c, or what would you have left if you put zeros in for x? And your y-intercept is a -7. Now we want to find 2 more points. Please substitute in these 2 numbers and tell me what the coordinates would be. If I substitute in a +1, I should have gotten 1, -2. If I substitute in a +2, I should get 2, 1. So now let's put it all together. My axis of symmetry, I'm going to draw a line at x equals 3. My vertex is at 3, 2. My y-intercept is going to be at 0, -7. And I do know that this parabola has to go downwards because my original a was a -1. Next, the 2 points that I found, 1, -2 and 2, 1, are now on the graph. And I could use reflection points. So here I go. 1 away. The orange dot is now 1 away on the other side. This was 2 away. This point is now 2 away on the other side. This was 3 from the y-axis. Now it's 3 away on the y. And then draw my curve. Do the practice problems on the sheet using Cami and turn them in.